Hello, I am Ashley Yu, and this is my Project 3 final project for Space Propulsions class. So to start, I already have geometry open. Again, we're going to draw our supersonic inlet. That's the free stream approach. Draw velocity, pressure wall. That's if nothing stupid happens. Draw another wall here. After that, draw our angled walls. That should be this. That, and then after we're going to angle our walls. The dimensions going to angle, and then but first, hang on. Actually, I think I have something. So 10.71, and then our second wall will be 22.55. 360 minus 337.49. Right, and then we can go into concept. Sketches, surfaces from sketches. Select our sketch. Why isn't it here? There we go. I don't know how it control there, but at the end, you can click generate. That is our inlet. Now we can go here and go to mesh. There we go. There we go. That should open up. There is our inlet. The first window to here is click on mesh, insert, face meshing. Click on the face, apply, and sure. Click on insert, click on sizing, select the edge, walls here, element size, put 2 centimeters for mine. There we go, and then click generate. should with the what happened? Let's try it like that. Oh, wow, why does it look like that? Hmm. Let's do number of divisions instead. 150. Hmm. What does I'll do that. I'll try to think of that. So back to this. Now we have to make our named sections. Velocity. Alright, sorry about that. I found what the issue was. The issue was that in here in face meshing, you have to put math mesh to no. So now my meshing looks like this, and after that, I can start creating my named sections. So we can go over here to edge select. We're going to call this insert name selection. Why doesn't rename velocity inlet? After that, back here, insert name selection. We're gonna call this top wall. Here we're gonna call this the free stream approach. Call these two names separately. This two, two. Name section. I'm gonna call this the pressure outlet. Why does it keep on doing that? Then right click on that, and then we're gonna go find create name section. What's this called? Wall. Yep. Why? I think everything here should be named now. Yep. Okay, so now I can move on to. As soon as I update this, I can move on to setup. Once this is done updating. Okay, now we can open setup. So precision, my computer has 4 cores, 2D. Yeah. Right, we should be able to get started in a bit. There we go, okay. So then we're going to go to our models first. We can turn our energy on. Change our solution to an inviscid one. Select materials, fluid, air. We can change this to an ideal gas. Just create, close. Next we're going to go into cellular boundary conditions. We're going to go to our velocity, and that I personally find that gives you better contours when you turn it into a pressure fluid. So that's what I'm going to do for this. Now Mach number is 2.12. Apply. Click close. Then check this real quick. Operating conditions. I think this should be 0. Actually, where is that? Right, 0 gauge. Okay, so yeah, everything's 0. Alright. And then after that, we're gonna go down to our operating conditions. Operating conditions is 101.325. Okay. And then we're gonna start initialization. Then we're gonna compute it. Step. Put it over here. Last minute. from our velocity inlet. Right when initialized. From calculation, 1,000 iterations. Calculate. And for that, doing that, then go back to our geometry. Then try to figure out how far from the x-axis this is. So go into our sketch, go into tools, analysis tools, distance finder. Oh, edge. There we go. I want to figure out how far that is from the x-axis. So vertex. Let's see. That's 1 meter, 1,064 centimeters. Write that down. That's our iterations coming right. And we're going to do the same thing for the other side. Actually, I think there's an easy way to do this. Yeah, 11356. 56. And then let's see here. So about 600 centimeters, I think we put our y at like halfway, 300 centimeters. You'll see why I'm doing that later. Looks like been fully converged, that's fine. This is just a video, so just keep going. Then to get our contours, you have to go into here, and it will show us all of our contours here. I'm not going to go to each and every one of them, but yeah, that's how you see them. Go save and display, and there's your contours. Why does it look like that? Hang on. I turn this. So I'll put this. I think it's 1,750. I think it's too close. And the calculation again. forgot that. I forgot to initialize. Right? Yeah. Why does it look like that? Uh, Hang on, I'll troubleshoot this real quick. Alright, well, I found one of the issues was that my pressure far field was misspelled, so just treating it as a bowl and not a pressure outlet. Yeah, over here, it's my pressure outlet. This still doesn't look that good, but that's the best I could get. I can't figure out any fixes for it, but we'll move on. And then, so by this point, you just look here for all your contours, and then after that, you go into XY plots. Not actually, you don't go into XY plots yet. You go into surfaces. You go to new line slash rake. Yep. And then you enter your points, which I closed Google because it's taking up so much RAM. Hang on, where is it? So or y would be, let's see, 200. And then our x here would be negative 11064. 1064. And then our here is, where is it? 1356. There we go. Create, continue. Surface creation failed. What? Why did it fail? Oh, because it's in meters. There. And that should work. And here's the 660 centimeters. That should be 3 meters. That should have. Then we go to new XY plot. We go to our new line. And now you have a plot. You do the same exact thing you did for the contours, and that would be it for this project. If you were wondering what it's supposed to look like, I have another. I can open up my old project. Here, I had to close this instance of Fluent though. Maybe it's gonna take way too long. I can just look in my Word project instead. This is what the contours are actually supposed to look like. A bit better than mine. Yeah, so that's it for project guide.